All right, I want to run through a couple of quick examples where we are going to determine the necessary sample size so that we can estimate the population proportion, uh, so essentially so that we can find a confidence interval. So, our example, a researcher wishes to estimate the percentage of adults who support abolishing the penny. What sample size should be obtained if he wishes the estimate to be within 2 percentage points with 90% confidence if, for scenario A, he uses a previous estimate of 24%? So let's dig into scenario A first. For scenario A, it's saying he uses a previous estimate of 24%. That is giving us our p hat. And we're going to turn that over to a decimal. So p hat is 0.24. For some of the other bits of information, it says that we want the estimate to be within 2 percentage points. So that's our margin of error. So our error is going to be 2 percentage points. So that is the same as saying 2%, or what we actually need to use is 0.02. Our confidence interval is going to be 90%. So if we have a 90% confidence interval, we come over and look at this table 1. So a 90% confidence interval, this means the area in each tail is 0.05, and we're going to have a critical value of 1.645. So our z sub alpha over 2 is going to be 1.645. Now, because we have p hat, whenever we look at these two equations, we're going to use the first one, these two formulas, sorry. We're going to use the first one for A because it has a p hat in it, because we have that information available. So n is going to be 0.24, so our p hat, times 1 minus 0.24, so 1 minus p hat, times our z sub alpha over 2, which is 1.645, over E. So that's going to be over 0.02, and then all of that's going to be squared. So I'm going to put that in the calculator right quick, which I went ahead and entered it, and we are getting 1,233 and some change. So part of the reason I say and some change is because we need to round up. I realize that 0.9 would round up anyway, but with sample sizes, you will always round up. So for scenario A, the sample size needed is going to be 1,234 people. Okay, and now for scenario B. We're going to go through the same process, only we're going to say that he does not use any prior estimates. So he's not using p hat in this instance. So for scenario B, we still have that our error is the 2% or 0.02. Because we're still doing a 90% confidence, we have our z sub alpha over 2 still being that 1.645. And we're going to use the second equation. And you'll notice that since we don't have a prior estimate, that we're going to be using the formula that does not have a p hat in it. So n equals 0.25 times our z sub alpha over 2, which is that 1.645 over 0.02. And then we're going to square that. I did not have that one entered in. Okay, and that's going to give us that our necessary sample size is 1,691 and change. And again, because we have to always round up with sample size, this is going to mean that we have to have 1,000 1,692 people. The reason that we're always rounding up with sample size is because we want to be at least 90% confident for this example. So if we needed 1,691 and a third people to be 90%, to be at least 90% confident, if we were to drop that down to 1,691 people, we wouldn't quite be 90% confident. But us bumping that number up to the 1,692 means that we will be at least 90% confident.